Our second speaker of the afternoon is Dr. Clayton Johnson. Dr. Johnson is a veterinarian and director of health for the Carthage system at Carthage Veterinary Service, located in Carthage, Illinois. He is one of 7 veterinarians dedicated to the swine veterinary practice. Carthage Veterinary Service also has a mixed animal division with a total of 5 veterinarians. Prior to working at Carthage Veterinary Service, Dr. Johnson served as the director of health and animal care at the Mash-Offs and oversaw the health services program as the company expanded from 100,000 to 200,000 sows. Areas of focus for Dr. Johnson include bioeconomic models of PRRS, PED, and Mycoplasma high pneumonia management strategies, swine veterinarian development and training, development of auditing and corrective action processes, and application of manufacturing theory and modern swine production systems. Dr. Johnson attended the University of Illinois College of Veterinary Medicine, receiving a doctorate of veterinary medicine, continuing on to complete the executive veterinary program. Today, Dr. Johnson will be discussing application of batch farrowing for disease control purposes. Please join me in welcoming our speaker.
All right, thank you for that very nice introduction. Can you guys hear me okay? I'm here today to talk to you guys about batch farrowing as a tool that could help to improve performance enough through decreases in clinical disease that it might be a viable tool for your operations. I've got some slides here that show you the impact of disease to start with. And to oversimplify what is a very busy slide here, we have got a lot of opportunity on our sow farms and our grow finish farms to improve performance from the 10th percentile, so the farms that are in the lowest performing category on this 2016 MetaFarms report, up to the top percentiles that we've got here. And really we can do that through better disease management. We heard that today, that one of the market drivers Steve talked to us about, that is as important as seasonality today is disease. I want to show you guys something that a public health professor shared with me as I try to think through how can we ultimately impact disease challenges and therefore profitability. And this is called the SIR triangle: susceptible, infected, and resistant. And you can use this for any pathogen in any species as you think through disease control options. Much like Paul just shared with us, you can eliminate a disease if you believe that you can live susceptible to it. You can control disease if you think that you're not going to be susceptible to it. But ultimately, you want to minimize the duration and impact of infection, whether that's being completely susceptible to it or ultimately going through the infection and controlling the disease. All animals live in this continuum somewhere. Don't think of these states as absolutes. You can be somewhat resistant, yet at the same time somewhat infected. Somewhat susceptible, yet at the same time somewhat resistant. So it's not absolutes. But where you're at in this triangle is important, and with populations, where the population exists within this triangle is extremely important. Most animals are going to be born susceptible to most pathogens, okay? And if we are not able to keep those animals susceptible, they're going to move to the infected category. Paul just shared with you examples of how we can do that with planned exposure, where we take control over the infection timeline, the dose, and how that actually happens. But that also can happen through natural exposure, as he shared with you as the industry's model through cedar pigs for mycoplasma management. That moves our pigs from susceptible into infected. Once we're infected, we generally try to use tools that impact the disease consequence, minimizing the clinical signs, decreasing the duration of infection, and specifically the tools we have at our total would be medications and vaccinations. And our goal with those is to usher the population of animals through that infection process with as minimal of unintended consequences as possible to get them resistant. And when we think about a sow farm or a production system perspective, if we can move our gilts into the resistant category, they will share that resistance to some level with their piglets through the passive transfer of colostrum. And our goal at the end of the day is try to usher these pigs, if we can't keep them susceptible, into the resistant category. And the focus of this talk will be about how we can use batch farrowing as a tool to help us manage that process. Pain is the ultimate motivator. It's one of my favorite quotes. If you want somebody to do something, pain generally helps to get that done. Positive reinforcement is a wonderful tool. It takes a lot of positive reinforcement to make things happen. A little bit of pain makes change happen in a hurry. And there is no greater pain than in poor performance of our pig herds. I don't need to go through all the information on this slide. If you guys are here today, you understand that sick pigs are major pain on your operation. And I think as our pathogen challenges change here in the US and globally, more and more people are asking themselves, should I think through some of my currently held dogmas like continuous farrowing and evaluate their opportunity to maybe help reduce some of the pain we've got? I want to share with you a couple of studies that demonstrate the pain of disease challenges and maybe where batch farrowing can be a tool that help it. The first study was done by Gabler et al. In 2013, and in this study they took a group of pigs, a cohort group of pigs, and they put them into two different facilities, a little bigger than feeder pigs at 30 to 34 kilograms. They then exposed one of the facilities to a wild type strain of PRRS. So intentionally made half of those pigs PRRS positive with a wild type strain of PRRS. The other population maintained a PRRS negative status all the way through the production period. And then they measured the performance results of both of these populations as they took them out to market weight, which would be about 130 kilograms. The punchline from their study was it took the animals longer to get to the final body weight. So if you're marketing at a fixed body weight, it took those animals about 2 weeks longer to get to market when they were infected with PRRS, which is kind of a yeah, duh type result. But there were some interesting things that they noted in terms of when that lost gain took place. All right, you can see here that there was also a feed conversion impact. The pigs didn't eat as much if they got infected with PRRS, but more importantly, their daily gain was impacted at a greater level. So feed conversion, which we know is king in a lot of the economics of sow production or of pig production, was impacted along with the daily gain impact. This chart here shows when those performance consequences were realized. So the black lines would be our PRRS negative population, and you can see the average daily gain here dramatically superior in the weeks immediately following the PRRS inoculation. And then here these pigs caught back up and basically performed the same after an initial 4-week period, but really never compensated, never had the full compensation of getting back to an end weight at the same time that the pigs that were never exposed happened. You can see the feed conversion impact somewhat similar. The feed conversion impact was really realized over that first 4 to 5 week period. After that, feed intake, feed conversion, average daily gain was relatively similar. So conclusions from this study would be that the duration of our disease consequence is extremely important. And the more we can tighten up that duration, the less of an economic impact the disease has. Show you another study here that's been a study that's commonly used and really some of the best available information that we have on co-infections. So the first study looked at just PRRS infection in a population of animals. This was a retrospective study that looked at multiple different infection possibilities in populations of animals. This study was done by Kara Hayden and some other very good people and presented at AASV back in 2012. Did it in a large production system in the Midwest. Was a retrospective longitudinal study where they went through both performance data and diagnostic reports to try and assign a disease status to groups of growing pigs. Specifically, they looked at PRRS and mycoplasma along with influenza, but really focused on respiratory disease to try and understand how much the disease status for PRRS and mycoplasma impacted the performance of the closeouts of groups of growing pigs. So a lot of intensive work to go back through diagnostic records and figure out which were our baseline groups, which were the groups that didn't have any PRRS infection, no mycoplasma disease, no influenza disease that was diagnosed, and then which groups fit any of the different disease categories. They could have had just one of those diseases, or they could have had multiple diseases. And then they did statistical analysis to understand, based on the category that you landed in, what diseases you had, how did it impact your closeouts? And they summarized it here as a difference in mortality as well as a difference in average daily gain. And the point that I want to make with this is that the diseases were not additive. That was not 1 + 1 = 2. It was often 1 + 1 = 3. And I've been on farms before with Paul when he talked about mycoplasma management, and I guess you still agree with this, Paul, but PRRS and influenza, we don't always have those tigers by the tail, right? And there's a big three: PRRS, influenza, and mycoplasma. The punchline with this is if you can remove a disease like mycoplasma from the equation, you may not be just removing 1/3 of the challenge, you may be taking away a significant layer of stress and disease that results in a dramatic impact to performance challenges. So don't let tools like batch farrowing dissuade you if you say, well, I'm still going to have flu, or I'm still going to have PRRS, I may still have mycoplasma. Just peeling back the layer of the onion one time may give you more than what you perceive as a performance impact. And in this study, they were looking at mycoplasma impact at being 63 cents a pig in this study. PRRS impact as being almost $6 a pig, but when you put those two together, you really saw a tremendous exponential impact to the cost of production, not an additive impact. So some summaries on the disease impact implications that we talked about here. Minimizing the duration of clinical disease has a huge impact on minimizing our performance impacts and ultimately the cost impacts of those. Unstable disease over long periods of time is the worst possible situation. Anything we can do to tighten up that disease, make it stable in a short period of time has huge value. And remember that susceptible, infected, and resistant triangle. That ultimately means we need to get out of the unstable category where we have all three of those animals, all three of those disease types present in the same airspace, and move those animals all to being resistant as quickly as possible, or susceptible if we think we can keep them there. And then ultimately the tools that can increase the percentage of resistant pigs, decreasing the percentage of susceptible and infected pigs is going to have tremendous value, and batch farrowing is obviously one way you can do that. Multiple pathogens that cause disease concurrently have more than an additive impact on each other. And so again, don't let batch farrowing dissuade you just because it may not get rid of all your diseases. Peeling back the layers of the onion one at a time may have a greater impact than what you perceive. All right, so let's talk a little bit about batch production specifically. What is batch production? What are the different ways that you can do batch production? And we'll start off with kind of the history of batch production. When I was a young man growing up, being shopped around by my father to various different pig farms in the neighborhood as labor, batch production was very, very common. It took advantage of the natural swine breeding cycle. It was very nice for a lot of farrow to finish producers that had a certain size of barn at different production stages, and they liked to fill that size of barn all in, all out, but they had to move based on time, essentially. The batch production model really worked very well. It also facilitated some of the early wean to finish transition, where now all of a sudden you had some bigger growing pig barns that needed to be filled with a large population, and the batch production allowed us to fill those barns fairly quickly. Multi-site production and artificial insemination were two tools that came into the industry that allows us to move to predominantly continuous farrowing. Continuous farrowing is difficult when you don't have multi-site production to be able to ship those wean pigs off-site, where you're not limited by a certain amount of nursery space that's literally right next to the farrowing house generally as your only place to go with your wean pigs. But continuous farrowing ultimately allows you to overproduce in the farrowing house. And if you've got segregated production with off-site locations all throughout the United States, you can get those pigs pushed out to different locations. You never have that constraint of, well, that's great, but I can't farrow another 10 sows right now because I don't have anywhere to go with the piglets when I wean them. Okay, and artificial insemination obviously made the breeding side of our continuous farrowing a heck of a lot easier. And continuous farrowing obviously starts with continuous breeding, being defined as just we're doing it every single day instead of in a tight time window. I want to show you pictures of a couple of different farms that I worked on and really describe to you kind of the traditional approach to pig production versus our modern approach with continuous farrowing that we use today. And as we go through this, think about the susceptible and infected and resistant categories we talked about. This farm on the left here is a traditional farm. I spent a lot of time on this farm as a kid. And it looks a little bit different on Google Maps now than it did when I was a kid, but I'll try and highlight some of the different areas of the farm for you. These were dirt lots, and pigs, sows were gestated and bred in these dirt lots. The breeding was by dumping boars in. Sows would get popped out of the farrowing house when they weaned, stuck them out on the dirt lot, fed them as a group, threw the boars in. The boars did the breeding for us, pull the boars out when we wean the next group, and move those from one lot to another. We move up now into the farrowing house. we had one big farrowing room up here that would farrow the entire group. So as these girls would be heavy bred, we'd go through there and use the very sophisticated method of looking at their underlines to figure out which ones needed to move into the farrowing house. We'd get them moved onto the gooseneck and we'd run them up into the farrowing house and we'd fill up the farrowing crates where they'd hang out for generally about 35 days. They'd move from that farrowing house as a group of wean pigs, so all of these farrowing crates would farrow over that 35-day period, they'd lactate, and they'd produce a wean pig, and we'd wean that entire room all at once and move them into this hot nursery right here. After that, that same cohort group would move into this grower building, okay, so we just keep adding groups, and then the finisher actually had 3 sections in it, so we would move a grower group into the finisher, and you were always pushed by your heavy breds. Your due to farrows always push the next stage of production. So as soon as you had a group due to farrow, you'd have to push them up here. The reason I highlight the susceptible and infected and resistant category is you're really talking here about all in, all out batches of pigs. Okay? So if you think of the wean pigs, they're going to become our market hogs. They start out as susceptible when they're born right here in the farrowing house. We get infected, generally at some point in the farrowing house. Unstable gilts with mycoplasma. All of the different endemic pathogens that these animals are going to see, they see a lot of them in the farrowing house and often very soon after birth. But they move through this infection process as a cohort group. And as they get out of the nursery, especially get out of the grower and move into the finisher, we really hope that at that point they're moving to the resistant category as a cohort group. So our populations are moving through this triangle together, and so you really never have subpopulations that are susceptible, subpopulations that are infected, that they can trade that pathogen back and forth and always serve as a reservoir of pathogen within the population to challenge the animals. Now let's look at continuous farrowing. This farm was actually built by this particular producer and a group of other producers as sow centers became a common thing. So they decided they want to get out of sow production, let's go in together, let's build a sow center, and we'll each take wean pigs out of there. We built this with a breeding and gestation barn here, a farrowing barn here, and you can see that that's very similar to how we build modern sow farms today. Now, the challenge with this is because all of these animals are in the same airspace, we call a room all in, all out in the farrowing house, but unless we're on true McRebel, we're generally moving litters around to tighten rooms up. We're cross-fostering pigs, and the reality is there's a lot of traffic back and forth throughout this facility. And so what was very segmented production here that facilitated all in, all out principles, now we've kind of moved to truly a continuous flow type situation where within the farrowing house, we have animals of all different disease status present at any given time. Now we move those animals off site and hopefully into wean to finish barns, so hopefully we minimize that. But the punchline is in the farrowing house, you've got infected animals that are always on site. You've got susceptible animals being born every single day. And you have some resistant, but you always have this unstable situation where your population have animals of different categories in it at all times, okay? Think of this room right now as an example. We're no different than the pigs, right? There are some of us in here that may have a particular pathogen. And if we lock the doors, we will achieve stability with a little bit of time, right? We may all get the flu if somebody came here with flu, same thing with cold. If we lock the doors, and we hang out in here for a little while, just like our populations with mycoplasma, they're going to eliminate it with a herd closure. We will eliminate the pathogens because we'll all move in the resistant category. If we open that door and every day 10% of us leave and 10% of us come in, it's going to be really hard for us to stabilize because there will always be some typhoid Marys in here that are infected and shedding a high dose of pathogen into the environment. Think of our pig farms the exact same way. All right, so the return of batch production. Important concept to remember here. Continuous production of the farrowing house is going to produce the most pigs out of the sow unit. That's very important to remember. We cannot forget that part. If your goal is to put pigs out of your sow unit, continuous farrowing is always going to be the most efficient way to use your farrowing crates to do that. However, depending on your disease situation, it may not produce the most pork out of your production system. Pounds of pork is ultimately what we sell if you're a wean to finish producer or farrow to finish producer, so that's something to keep in mind. Your endemic challenges are going to be increased with this continuous production, okay? Your batch production will improve your wean pig health. Those are some basic principles that I think you can think of with batch farrowing, all because of the susceptible and infected and resistant triangle. Now, the principles of batch farrowing were helpful to disease in the 1980s, 1970s, 1960s, and that was when we didn't have a whole host of pathogens that we fight on a regular basis now. Even in my relatively short career, the list keeps growing and growing of pathogens that we have to worry about, and even pathogens that historically maybe were there, but they weren't really big deals. Now they are big deals, and we don't always have good tools to control them from a vaccine standpoint, from an antibiotic standpoint. So we just have to recognize that as the disease consequence becomes greater, this whole theory that batch production improving your disease challenge, because these are oftentimes endemic diseases in our pig populations, it's going to have a bigger impact now than maybe even it did previously. So I've got a benefits and negatives slide here. We'll start with recognizing some of the benefits of batch production. We've talked about how it can improve your endemic disease control. I do think batch production can help facilitate disease elimination, if that's a goal. Whether it's a PED that popped up and you never wanted it, or whether your goal is to produce a mycoplasma naive population out of a sow farm, I think that batch production can help you to do that by stabilizing the health status of your farrowing house. I do think that batch production can help you return to normal health after an outbreak, and I've worked with a couple of farms that have used batch production specifically for that. I get PRRS every year, sometimes twice a year. It drags on for months and months and months. Batch production is a way to minimize the time it takes you to get stable and or truly negative for that pathogen. And then this right here can be a huge plus as we think about labor. And everybody knows how precious labor is right now. If you've got a good breeder, if you've got a good day one person, those people are worth their weight in gold. And if you can use those folks and move them across more animals, because you're moving them across a facility, leveraging their skills at breeding across a larger number of animals, farrowing, processing, you can maximize their labor specialization. And I think that's something that you got to think as a potential positive of batch production. Some of the negatives: it will be less efficient use of your farrowing crates. Your farrowing crates are solid gold real estate in your farm. They are the only place in your farm you can farrow an animal. I can breed an animal anywhere on the farm. I can breed her in the GDU, I can breed her in gestation, I can breed her in a farrowing crate. I can gestate an animal anywhere on the farm. I can only farrow in one spot of the farm. So you should always try to look at that as your bottleneck, and you want to make sure that farrowing crate always, not always, that's not possible, but has pigs lactating in it as often as you possibly can, because you want to maximize that. That will always maximize the throughput of your sow farm. Batch production won't do that. You will have more days of animals in your gestation or in your farrowing crates where they are not lactating, or more days where your gestation or your lactation crates do not have animals in them, period. There's generally going to be a wean age and or a PSY consequence. And depending on what batch system you use, it will vary. Some batch systems are a little more forgiving on your wean age consequence. Some are more forgiving on the throughput. Pros and cons. There's not necessarily one that's better than the other. And then this whole labor specialist and surges in labor needs can be seen as a con as well. If you're an individual farm that is doing batch farrowing and you have no ability to rotate labor, that can be a big challenge. The days that are farrowing days, the days that are breeding days, those are big, big days. And even on a relatively small farm, a 2,500 head sow farm, that's a lot of animals farrowing at one time. And guess what? The animals don't know when holidays are. The animals don't know when there's an Iowa State-Iowa football game, right? The people on the farm have significant life impacts if they are working on a batch farrow farm, and that's the only farm that they call home. And that can be a real challenge for people. So it can be a blessing, can also be a curse. All right, let's talk about some of the challenges that come up and some of the opportunities to overcome them. Gilts are your first challenge with any batch production system. We have asked the gilts to come into heat during the week we would like to match the breeding cycle. They have yet to comply with that request completely. Our opportunities to try and get around that natural variation and when they first come into heat are to use a common gilt pool to multiple farms, and that would absolutely be the preference, okay? So if you've got a common gilt pool where you can do boar exposure, you can do H&S's, you can identify animals in heat, then push them to the farm that's breed week matches with their natural estrus cycle, that is a home run. There are also some wonderful hormone technologies that are out there that can be used to drop animals into an appropriate breeding week as well. Those hormones can be very effective when done absolutely correct. Same time, same day, and that can be difficult to execute and certainly comes with some cost. Recycles are variation challenge number 2. Similar to the gilts, they do not happen when we would ideally like them to happen, and they fall out of group often when they do recycle, and we find them as an opportunity to breed again. Okay, with batch farrowing, we're only breeding in a defined time window, so your recycles will pop in sometimes when you're not breeding. Couple of options that you can do there. You can certainly transfer those recycles to a different breeding group using the hormones, just like we could with the gilts. There's also physical movement to another farm. So if you have a sister farm where you stagger the batch, that can be a nice tool. Comes with some disease risk, but we got to be honest with ourselves. Sometimes those sister farms have the same disease risk anyway. And then the other one is you can actually increase your replacement rate. You can just say, all right, those animals that raise their hand and recycle and tell us they are not part of the breeding herd right now, guess what? They're likely to do that again. So you can up your replacement rate and just say, all right, we're done breeding recycles. They're going to leave the farm when they happen. Your farrowing and breeding dates, we talked about this a little bit already, but it will inevitably happen where you are farrowing hundreds of animals on Christmas Day. There's nothing that you can do about that. If you've got the ability with multiple farms, and you'll hear this repeated a lot, if you've got the ability with multiple farms to pod this up so that you're sharing your labor and you're rotating your specialists to the farm that's doing that task at that point in time, that can be that can really turn this negative into a positive. So rotating your best farrowing labor is the preferred route. If you've got to shift labor from other parts of the farm, you're going to have a lot of people who are generalists on that farm. I breed this week, I farrow next week, I process the week after that. That's a lot of technical tasks that I have to learn and be good at. And the reality is I'm probably never going to be as good at all those things as if I just get to specialize in one task. So being able to share labor, much like sharing gilts across multiple farms, is a huge advantage if you've got that capability. Nurse sows, it is hard to have nurse sows available in a batch production system because you're almost always going to target over farrowing. Because of the inefficiency that's already present in your farrowing house, you want those crates full, you are going to breed more than what you normally would. You then don't have any room for nurse sows, and you don't have any nurse sows hanging out. You're not weaning animals every couple of days to have nurse sows available. You're not farrowing animals to have fresh sows available. So that can be a challenge. One of the opportunities here is to use a milk deck or a rescue deck. Throw pigs that are a couple days of age or older into it. I would tell you if you do that, your immediate tendency will be to go pull fallbacks and throw them in there. That is a scour nightmare. Do not go down that pathway. If you're going to use the milk decks, pick the best litter in the room. Keep your litter integrity tight, move those animals into the milk decks, take the sow you just cleaned off, she is now your nurse sow. That will keep those milk decks from becoming an absolute scour disaster, and really probably the only way I would recommend using them. Okay, so now let's talk a little bit about different styles of batches that are out there. We'll talk about 4 different styles of batches. The first major difference between them is some are all in, all out. So the farrowing house is all going to farrow at one time, all going to wean at one time. Some are going to be split into 2 groups. Okay, so that's the first difference that we'll talk about. The other is going to be the duration of the breeding cycle. So how many days am I going to allow the sow farm to breed across? Okay, the more I tighten that up, the more I add to some wean age. The more I'm going to turn my farrowing house generally. The longer I extend that, maybe the more breeds that I can catch, but there's a consequence to that, certainly on wean age. So we'll talk about all in, all out batches first, and I'll kind of go through these with a similar template of slides to explain them to you. A 5-4 batch is when you have 5 groups of sows that farrow every 4 weeks. Okay, you'll hear this called a 4-week batch pretty often. You're going to have some wean age impact to this, some of the worst wean age impact that you will have, because you have to turn that farrowing house completely every 28 days. All right, your heavy breds are coming, you have to wean. So if they did not farrow until the end of the farrowing group, so maybe day 5, day 6, day 7, day 8, when loaded into the farrowing house, they're going to have some pretty low wean age. So this model right here has the biggest wean age impact of the all in, all out options. However, it's going to be one of the best for throughput. You're going to be turning those crates pretty hard. And this is always the case with wean age. It's an inverse impact to your number of farrowings. So you're going to turn more pigs through the farrowing house with this. They're just going to be lower wean age. Whether that's good or bad, entirely up to you and your situation. To try and demonstrate to you kind of what that looks like, in our little example farm here, we've got a farrowing house, which has got the first group that we bred. If we pretend this is a new farm startup and we had a whole bunch of gilts to breed on, the first group that we bred is going to get loaded into the farrowing house first. And so let's pretend that they're in here. The second group that we bred, which starts 4 weeks after the breed day on the first group, is going to be here. And there's going to be 4 groups in gestation while there's 1 group in the farrowing house. And that's always the way the farm will look. You're always going to have 1 in the farrowing house, 4 groups in the gestation. You start your breeding cycle 28 days after the last breeding cycle ended. Just for the purposes of trying to give you some dates, I made an assumption that you're going to do 5 days of breeding. That's entirely up to you how many days of breeding are actually going to happen. Remember, as you extend that out, your average wean age is going to go down, and particularly the young wean age pigs, the number of those is going to go up. Your days of gestation is relatively fixed. I did assume that you got 3 empty crate days, okay? So I wean, I wash, I load, and I've got 3 empty crate days. That is probably your biggest opportunity to tighten this thing up and help with that wean age impact. The more equipment and labor you can throw at getting that farrowing house turned, the more wean age you're going to add to that. And particularly the number of power washers that you throw at that can have a huge impact. All right, and this assumes that you're going to load at gestation of day 112 for all animals. As we know, gilts farrow early, so that can be a little bit of a challenge, but that's really how this model plays out for a 5-4 batch. The next all-in, all-out option you've got is a 4-5 batch. So in this situation, you have 4 groups of sows that are going to be bred every 5 weeks, farrow every 5 weeks. Very similar to the previous model, and that your farrowing house is going to be run as an all-in, all-out group with 1 cohort of sows that get loaded in at the same time. They hang out in there for a 5-week period, then they're all weaned at the same time and they move out, okay? You're gonna farrow and breed generally over a longer duration in this model. It gives you, because you've got 35 days in the farrowing house, you've got a longer time to catch breeds for animals that come into heat a little bit after day 5, day 6, day 7, day 8. You control the breeding window, which controls your farrowing window, so you can manipulate that however you want. You'll end up with a pretty big spread in wean age the more you extend that breeding interval. If you tighten up your breeding window, you'll tighten up your farrowing window to some extent as well. Same graphic, same assumptions, except we used 10 days of breeding in this particular model, so we gave ourselves longer to catch breeds. You've got 3 groups in gestation instead of 4, but you're still all in, all out in the farrowing house. And you're going to add overall wean age to this, but you're doing that at the consequence of the number of sows that farrow every single year. So less pigs that go out, but more wean age on those pigs. All right, so now let's look at when we take our farrowing house and we don't do it all in, all out. We split it into 2 different sections. So you've got 2 groups in the farrowing house at any given time. That may not be a bad thing at all if you have 2 different farrowing houses. If those are 2 physically different facilities, you may say, well, that's basically all in, all out. I got different employees working in there. I'm not tracking pathogens back and forth. I can do the susceptible, infected, and resistant thing in 2 different facilities. If it's all in one, all under one roof, that may be a little bit different. But probably a little less health advantage with this, but you get a little bit more throughput kick with it. A 10-2 batch is the first one that we'll talk about when we split the farrowing house into 2 different sections. You've got 10 groups of sows that farrow every 2 weeks. You're going to turn half of the crates in a 4-week turn, okay? So every 2 weeks, you're weaning. Every 2 weeks, you're breeding, all right? Your wean age, much like the 4-week model, is going to take a hit in this one, all right? You get more throughput, but your wean age takes a bigger hit. Here you can see the graphic representation. You've got to split your farrowing house into 2 different groups, one way or another, whether that's just rooms 1 through 10 are on this batch and rooms 11 through 20 are on this batch, or we've got 2 different facilities. Either way, you've got to split up your farrowing house into 2 different groups. And then you've got 8 groups that exist in gestation at any given time. And you are breeding on a 14-day interval. So group 1 got bred starting on day 1, group 2 got bred starting 14 days later. Same assumptions that were used down here for the 4-week batch. The last option that we will talk about for your lactation space being split into 2 different groups is a 7-3 batch, okay? And much like the difference between the 4-week batch and the 5-week batch, you've got the same pros and cons. So in this situation, you have a longer window to breed your sows. You can get more sows into the group because you just have more time to breed. You also have more time in the farrowing house. You'll have a big variation in your wean age most likely, especially if you push how long you're going to catch those breeds. but you will have your average wean age increase with this particular batch system. Here's what this looks like physically inside the barn. You've got lactation split into two just like before. Longer breeding window assumption, very similar to the comparison of the 4-week and the 5-week. In this situation, you're going to get more wean age on these pigs. You're going to wean at a later time than the wean day here in the 10-2. So you've got more wean age on those pigs, but you're doing that at a sacrifice to throughput. Okay, there's no right or wrong. All these models may be best for your particular situation. Here's an example right here of the transitioning from continuous production to the 5-4 batch production. I won't go through this in any detail. Group 1, you would skip it. So if you're going to go to a 4-week batch, group 1, when they wean, you just skip them and they'll fall naturally into it. The next 2 groups, you're going to need to use some hormones to push them into the 4-week batch. And you can see in here, you're not going to do any breeds for a 4-week period. You can never recapture those breeds. All right, it may seem like a small thing in the grand scheme of things, but you need to think about the financial consequence of that, because the farm will start and end at the same amount of time. You're never going to capture that 4 weeks of breeds again. You'll breed the animals just later on. Okay, so there has to be some evaluation of the cost of that. I apologize, Chris, I must have sent you the bigger slide set. So I've got some case studies in here that I will probably skip through in the interest of time, because I know we're running late here. I will absolutely acknowledge Dr. Lise Tuhill. She's an excellent veterinarian because she's been referenced in the last 2 presentations. I worked with Elise at Mashoffs, and we worked on a couple of farms that we switched to batch farrowing because the disease pressure was so great, we had to do something. They were always PRRS unstable, and as a result, they always had to be flowed by themselves. That was a disaster in the system we worked in because we had generally large finishing sites. So not only did you have disease unstable animals, but they would fill in a wean to finish barn over 5 weeks, 6 weeks, 7 weeks. And that was a horrible situation. You think about that infected, susceptible, and resistant model, that is just a disease soup that you can't live in. Put these farms into a batch. They're located very close to each other, and they have a common GDU. So they could take advantage of a couple of those key principles that I referenced multiple times. They can share the gilt developer, so they have to have less manipulation of the gilt cycle to put them into a breeding group. And they were able to rotate employees back and forth. We essentially consider the 2 farms to be one health status. Some nice trivia on this farm. One of the reasons why we had the disease challenges is this is a packing plant, a large packing plant that does around 16,000 pigs a day from all over the state of Illinois. Here would be sow farm number 1, about 1.7 miles away, and here is sow farm number 2. And if that's not enough danger in and of itself, that center pivot right there, if I remember correctly, helped to remove some of the effluent from the packing plant. And this direction is west, and in Illinois, the wind generally comes from the west. This is the drive into the farm, and you generally got a nice spray if you drove in at the right time. And if you were really lucky and the wind was right, it'd actually blow the pivot onto the sow farm, which made it really nice. But that's the reality of pig production, right? If we could go and do all this over again, we'd do some things differently. The reality is we have multi-million-dollar assets sitting there. We have to make the best possible situation out of it. So we push to put these on a batch. And I'll skip through these some real quick to kind of get you to the punchline. Elise did a nice job of summarizing the impact to the farms. The outcome there, she's got it in previous slides, how rough some of the performance was. But we looked at the mash-offs as a % loss on a weekly basis, okay? So that's a little different than a lot of people look at mortality, but what percentage of your growing pigs, all the pigs on feed within a flow, what percentage of those pigs died on a weekly basis? That was a number we routinely looked at, and we were able to knock this down to a very acceptable level. And while 87% pigs go into a primary market and wean to finish groups may not sound like a slam dunk best production ever, it was a massive improvement over where we had lived with PRRS unstable production, 5, 6, 7, 8 week fills, and it certainly made life a heck of a lot better. And I will apologize, I'm going to flip through several slides here so that I don't steal your break. I definitely want to throw in some of the lessons learned that I've gotten from going to batch systems over time. If you can get to all in, all out, that's going to provide your greatest health advantage. If you've got 2 farrowing houses and they are different facilities, that may be a different story. But going to all in, all out production in your health, in your farrowing house, no matter whether you're fighting a really bad scour issue or a reproductive deal post weaning, that's going to provide the biggest health advantage. So if health is your ultimate goal, make sure to keep that in mind. Your hormone program has to be managed perfectly. Same dose, same time, every single day. If you want to get good results, it's got to be done perfectly, and that's very difficult to do. Make sure your employees know how sensitive it is. We'll get that done at the right time. You're generally going to want to overbreed. So you're going to want to overbreed. Why? Because you're going to have sows that farrow and die. You're going to have sows that farrow and don't milk. Okay? They are going to naturally remove themselves from the farrowing house. If you're farrowing over a 7-day window, the ones that remove themselves early can be backfilled with the ones that were bred towards the end of that group's window. So they hang out in gestation until close to the breaking point. Then you come backfill those crates with those last animals so that you have as full of a farrowing house as possible. Cull your poor performing sows. It's really an opportunity to get those animals that raise their hand and they say, I'm not a good reproductive performer in this herd, get them out of the herd as quickly as possible. You can do that more aggressively here than in continuous farrowing. If you've got the ability to rotate your labor, that is a huge advantage. If you can take your best day one people, your best breeders, and get them to the most number of animals on a regular basis, that's a huge advantage, and it prevents them from becoming overworked during the 1 week in which their activity is going on in the batch. If you can use a common GDU, that's a huge advantage. Huge advantage because you can push your gilts based on their normal estrus cycle to the right breed groups on the right farm. And then ultimately, think about the additional equipment. Power washers. I can't emphasize that enough. If we need 1 power washer or 2 power washer to wash the farrowing house and have a 3-day turn in the farrowing house today on continuous farrowing, we need more than that on the batch, okay? Don't let equipment and supplies be a restriction. You're gonna have lots of labor that's available during that period of time. Don't make the lack of a power washer, or certainly not the lack of a working power washer, keep that labor from being effective. And then little things like processing carts. Everything you do, you're gonna need more of. So it may mean some of the supplies, we kind of take it for granted that every farm needs 1 of these or 2 of these. Well, you might need more of those to get the same amount of work done and minimize your downtime, which improves your efficiency. All right, batch and farrowing, to summarize, I mean, it's got significant health improvements that I think we all would recognize. The endemic disease control is gonna be better, and your epidemic disease recovery, when we get PRRS, when we get PED, we get Delta coronavirus, we'll go faster. And we know from those studies that the shorter we can decrease that window of disease, the smaller the economic impact will be. Some cost to consider if you're thinking about going to a batch. You've got the cost of conversion, so you're not going to breed anything for a couple of weeks. You may have to use some hormones. You've got to think about that. You're going to have increased non-productive days on your batch. There's no ifs, ands, or buts about that. Wean age impact, depending on what batch you go to, you need to value that. And then the throughput. And again, these are generally inverse with each other. You can choose batch systems that are very forgiving on the wean age. They come at a throughput consequence, and vice versa is also true. I would tell you to make the decision, weigh your total kilograms or pounds of pork produced, your wean pig cost impacts based on your total pork produced, and then your conversion costs and revenue impacts. And I know that's a gross oversimplification of the math that has to be done, but ultimately those are the things you have to account for as you consider is batch farrowing the right thing to do for me. So with that, apologize, I may have taken a little bit too much time. If there are any questions, I'm happy to answer them. All right.